So, hi, how are you? Fine. First of all, I welcome to all of you on Gupta Sir Math YouTube channel. Right. Okay. Now, today is the first class on ninth class math that I am going to start. So, we'll discuss the today's introduction class. So, we'll discuss complete chapter of ninth class that maths covers. Uh, you can say CBSE board and all state board, right? CBSE board, state board, ICSE board also. Okay, we'll cover. You will get the complete chapter from the basic because whatever I start from the grassroots level. I discuss with the grassroots level. So everyone will be beneficial, and this is going to be a very much important class. So no need to go anywhere and no need to visit any type of institutions, no need to visit any type of coaching center, right? If if you ask me, if you you can start sincerely and you start sincerely, this is my advice and this is that as already discussed because practice is the math mantra. Yeah, if you want to make your friends math, then you have to practice at your home. So, whatever I teach, whatever I discuss in the class, you must practice at your home. If you don't practice, it is not going to helpful for you. But if you practice, it is going to helpful for you. Today's introduction class, that first session I will discuss something. I will discuss some exponents. I will discuss some topics and detail from the next class I will discuss. So this is going to very much important class, important series for you, and we will be together for a long time till your complete chapter is finished. So I want to recall my channel's name again. That is a Gupta Sir Math Hub YouTube channel. So if you like, you can subscribe. If you like, you can like or share. Okay, it is motivations for me. And suggest others also if they do not get time to attend the class, they can visit my YouTube channel, right? And they can have a playlist, and there also that is a class 9 maths playlist. You will get all the details chapter wise, that I emphasize on chapter wise. So if you want to learn chapter wise, you certainly follow me, right? You must follow me if you want to learn chapter wise. If you want to learn from basic, if you want to start from the basic, you must follow. So let us start without wasting your time. And this is not time waste, just I am going to discuss with you, right? But have some patience because everything I will clear, that I am confident, right? And if you are not clear, if you have any type of doubt, you are most welcome. And I request to you, please put into the comment box whatever you want. Any topic, if you feel that it is not clear, any chapter, if you feel that it is not clear, then you can put it in comment box or you can mail me, right? So there is no issue. And I would be happy to reply your mail, your comment. Thank you. Okay. So now we'll start the introduction part. That is the first topic that I am going to say you, discuss you. That is the exponent part. That is exponent, right? Some law of integral exponents, right? We'll discuss law of integral exponents, right? Okay. We'll see with some examples. We'll discuss with examples. right? So we'll go in detail, right? Chapter wise. Okay, chapter wise. Chapter means chapter wise. Basic ideas I will clear, basic concept I will clear. So if you clear with your basic concept, that I guarantee that you are clear with all type of maths, right? I prepare the child such as that he can do well in any type of exam, whether it is a competition exam, any type of competition exam, whether you appear for any type of schools exam, government exams, and any other competitions exam, right? So if your basic is clear, I think if basic is clear, everything is clear, right? So I am going to clear your basic. Some basic concept regarding the exponents, as you have already read in a previous class, just we are going to remember that once again, right? We are going to remember that, which will be very, 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 very helpful for you, isn't it? So, now the first rule that I am going to discuss, that is a to the power m and a to the power n equal to a to the power m plus n, right? We are going to discuss this one by one. We'll see it how it is solved. Just this is a, right? Just this is a practice, right? Okay. So what is meaning of this? Why I have written a to the power m into a to the power n equal to a to the power m plus n? Why I have written? Okay. What say this, right? With this, what do you get? You get the two things here. First thing, this is the left hand side and this is the right hand side. Okay, left hand side you are seeing base is same. Base is same. This is A and this is A. So it means base is same, but powers are different. But powers are different. So in this case, what we solve this, A to the base will be same. Base is same A and power is added, right? We'll go through one example so that we can clear it, right? Suppose question is, you are given 2 by 3, you are given 2 by 3 power 5 into 2 by 3 power 8. That you are given to solve this. Now how you are going to solve this, right? How you are going to solve this? This is a magic here, because that you know this formula, right? This mantras of this problem, that if basic are same, then powers are added. If basics are same, then powers are added, right? Gentlemen, please remember I am going to chapter wise, right? So you have to cooperate with me, because I have to take all the candidates together, right? Thank you for your support. Okay, no issue. I will go through the basic wise. No issue, right? So now the basic 2 by 3, this base is same, that you are, what you see here, base is same, 2 by 3 is base, 2 by 3 is base. So now as per this, what will we do? 2 by 3, 5, right? Base it is written here. So I have written the base 2 by 3 as it is this. Written the base, correct? Now power is added. So in place of m, here it is a 5. In place of n, here it is 8. In place of m, here it is a 5. Getting my point? Getting my point? So power is added. Now it is 5 plus 8, right? So answer will be 2 upon 3, 30. What is that? What is that answer? 2 upon 3, 30. 5 plus 8, 13, because power is added. So 5 plus 8 equals 30. So this will be your right answer. With this, we have cleared number 1, right? A to the power m into a to the power n equal to a to the power m plus n. So you can read it as a raised to the power m multiplied by a raised to the power n. So result is a raised to the power m plus n. In the sense, just I repeat it again. If base is same, power is added. If base is same, power is added. Okay, no issue. I will take one more example. All that I have promised, I will clear. Means clear, right? Basic will be cleared, right? I will take one more example. So you can note it down. Okay. So I am going to delete this. Now, we'll take one more example. As you have asked, right? That we have to take one more example. What is that example? Suppose here it is, I will take something different. 3 upon 5 to the power minus 3, right? This is a different sum minus plus, okay, minus 3 into again 3 to the power 5, here it is a 4, right? Here it is a 4. So what will be the answer now? Question starts, what will be the answer? So gentlemen, remember one thing that is a more important. What is that? Base must be same. If base is not same, then we cannot follow this formula. But condition is this, their base must be same. What is the base? Why it is same? Here it is a 3 by 5, 3 by 5. So here we get base is same. Base is same, right? So again we write here base 3 upon 5. Again minus 3. We write here minus 3 and plus 4. Because that you know, as per the properties, as per the formula, if base is same and it is a multiplied, so their power is added. Their power is added, right? So now, what is the result? Result is 3 upon 5 power 4. This is a minus plus minus. So 4 minus 3, 1. 1 sign, what will be sign this one? You must write the sign also. Don't forget to write the sign. If you are forgetting to write the sign, complete scene is changed. Right. This is another thing. That one is not written, because if you do to power 1, so result is same, right? So minus 3 plus 4, here it is plus 1. So you can write your answer 3 by 5 is the right answer. Clear? It is clear? It is clear. So I have taken 2 examples for you, and now we'll see some other law. So this is called the first law of integral exponents. What is called? This is called the first law of integral exponents, right? Now we'll go through the second law of exponents, right? So I am going to delete this. Please note it down or have a screenshot, right? Okay. Now we'll see some second law, right? Second law. What says the second law? Okay. Okay, this is very much important. This is going to help you in the exam. This is going to save your time. This is going to solve your questions within a seconds. Within a seconds. If you don't remember this, so it will make no sense if you don't remember this. Okay, now we'll see the second law of integral exponents. Now what says the second law? Right? What says the second law? Now a to the power m and a to the power by a to the power n. So this says m minus n, right? Or in other word, you can write a to the power m divide a to the power n. So result is m minus n. So this both are same. This both are same. There is no difference at all. Right? This both are same, and this is called second law of integral exponents, right? Which is a very much important, and it is going to have a more impact on your exam, right? It will have more impact in your exam. So we'll see attentively, right? Come on. Now you will see that base is same. That one of the most important criteria you must remember, that base is same. And base is same, if you remember this, means the base is same. If base is same, then only you can follow this. Otherwise, you cannot follow this. Right. So base is same, a to the power m, a to the power n equal to a to the power m minus n. It is correct. Right. Correct. So a to the power m upon a to the power n equal to a to the power m minus n. Okay. Now you see, we'll take some examples and we'll see it one by one. That if you take, suppose, 4 upon 5, okay, and it is here 5, power 5, divide 4 upon 5 power 3. What is the result? What is the result? That, gentlemen, a to the power m upon a to the power n in the same sense is described here, a to the power m divide a to the power n. So we can write in this is in a divide function. Again we can write in this way also. So there is no difference in this way also. Right? So I have taken this example in this way also. Right? So question is 4 upon 5 raised to the power 5 divide 4 upon 5 raised to the power 3. Right? Now what will be the result? So certainly you will say that, sir, base is written as it is given and then power is deducted. Power is deducted because in divide power is deducted. You must remember, before this in first law of integral exponents we have seen power was added, but here in the second law, if it is in a divide function, then power is deducted, right? So you must write whatever power is this. So this will be m minus n. We cannot write this power minus this power. Sometimes this power may be more. Try to understand my point. Sometimes you will get in the question this power is more and this power is less. But that doesn't mean that you will minus from the more power, right? No. We have to follow the rule. If it is here whatever written here as a power, that in that power this power is deducted. This is the right answer, and we'll take one more example with this and I will clear you. So now result is 4 upon 5, 5 minus 3, 2. This is your right answer. If they want answer in other way, so you can write 4 upon 5 into 4 upon 5, 16 upon 25 is the right answer. Both answers are correct. There is no issue. Both answers are correct. There is no issue. Now you can have a screenshot and we'll see some other example also. As I have told you that if power is different, right? Somewhere this power is more, this is a less. That doesn't mean I will deduct from the more power. No. Come on, we'll take some one more example so that will clear your doubts, right? You can have a screenshot now. Now we'll take some more examples. Now come on. Now the next example is, as I have discussed, that 2 upon 3 power 2 divide 2 upon 3 power 9. What is the result? Now this is a power 9 and this is a power 2. This is a matter of confusion. That sometimes what children think that I have to take the more power first, then we'll take this 2. No, this is not correct. This is not correct, right? So what is the correct? That I have written here m minus n, so it is in place of m and it is in place of n. So we'll write here 2 upon 3, 2 minus 9. This is very correct. 2 minus 9, right? We cannot write 9 minus 2. No. That will be wrong, right? That will be wrong. So we'll write 2 minus 9 as per the formula, right? Now, what is the result? 2 upon 3, this 2 minus 9 result is minus 7. So this is your right answer. It is clear to you? It is clear to you? It is clear to you? Right. So, we'll move towards some hard problem, right? So, first of all, we'll do some easy, then we'll move towards the hard problem. But that I have promised, I will take the questions from your chapter one by one. All chapters I will clear from the basic, right? Okay, from the grassroots level. Please remember this, right? Have some patience. All doubts will be cleared here, right? Okay, so 2 upon 3 equal to minus 7 that I have written, right? Okay, now that I am going to delete this, we'll take some third law of integral exponents. As per this, I have cleared your doubts with the two examples, right? With the two examples. Clear? Now we'll see some other case, right? What is the third law of integration? What is the third law of integration? So third law of integration that I am going to discuss, that is, just I am going to delete this, right? Okay, you might have noted this. Now, we'll see the third law of integration, third law of integral exponents. Third law of integral exponents. What says this third law? A to the power m, or here it is n. So result is m into n, right? A to the power m and again that power n. So result is just base will be written and this power will be multiplied here as it is. This power will be multiplied, gentlemen. This power will be multiplied. This power will be multiplied. So, gentlemen, we'll take some very good example that will clear all your doubts. What is that example? Just we'll have very good examples, right? Now, okay. So, what is that? What is that? Suppose it is written here 2 upon 3 and power is 5. Again, power is 6. Right? Just see the question. 2 upon 3, power is 5. Again, power is 6. 2 upon 3, power is 5. Again, power is 6. So how we are going to solve this? How we are going to solve this? So we'll take here the very easy that I have expressed here. This, as you know, this is the third law of integral exponents, right? That I am going to discuss. So as per this, m into n. As per this, m into n. So power is multiplied. Certainly in the very short, you will write here 5 into 6. So result is 2 upon 3, 30 power. It is the correct answer. It is the correct answer. It is the correct answer. No issue. I will take one more example. I will take one more example. No issue. I will take one more example. Right? Okay. So you can note it down and we'll have one more example. That is how we are going to solve some other type of questions, right? Some other type of question. We'll have one more example, right? Okay. Now we'll discuss that when m is less, that I have already discussed with you in the previous. But in detail, we'll take some questions and just now I am trying to clear your this question based on this law of exponents. But in detail, we'll discuss this. So today is introduction class for this. The first chapter we are going to discuss from the class standard 9 mathematics, right? For all the boards, that is a CBSE and all the state boards, even ICSE boards you can include. There is no issue. And some children think that ICSE board is very much hard. No, it is not hard. right? If you are clear with basic, then everything is clear, right? It will work like a magic. It will be a magic, right? But you must have some patience. I will clear, right? So 2 by 3, that is a 30. Right answer, 5 into 6, 30. Okay. Now we'll take some another example. What is that? Okay. Now, another examples, suppose question is given 5 in bracket, here it is 3, here it is 2, again power minus 3. Getting my point? Minus 3, right? Okay. Now. What should I write the answer? What should I write the answer? What will be the answer? Anyone? Anyone from your end? Anyone? Anyone means anyone. Anyone can reply. Anyone can reply. What will be the right answer for this? What will be the right answer for this? Anyone can reply? Okay. Okay. You cannot done these questions, right? Okay. So, how can you solve this? First of all, that you know that a base, if m into n power m to the power n, then we can write m into n. Here also you can multiply all these three power. There is no issue. You can multiply all these three power, there is no issue. You can multiply all these three power. You can multiply all these three power, there is no issue. Right? So what will be the answer? Answer, gentlemen, answer will be 3 2 ja 6, 6 3 ja 18. So answer is minus 18, power minus 18. It is correct answer. It is correct answer, right? It is correct answer. Getting my point? Getting my point? Okay, good. Now you can note it down and we'll see some another that is a law of integral exponents. Right? We'll take some another law of integral exponents. Right? Okay, this is the third law. Now we'll take the fourth law. Fourth law, what says the fourth law? What says the fourth law? Right. What says the fourth law? Okay. What says the fourth law? Suppose question is given 5 to the power 5. Right? Getting my point? And again divide 5 to the power 5. So what is the result? What is the result? This is the fourth law, gentlemen, that I am going to discuss with you. This is the fourth law that I am going to discuss with you. Okay, what says this fourth law? Right. So if question is given 5 to the power 5, divide 5 to the power 5. So as per this question, how will you solve this? You can write, you will say that sir 5 minus 5, because in divide power is subtracted, power is deducted. So you will write here 5 to the power 0. So gentlemen, what is the meaning of this 5 to the power 0? 5 to the power 0 is always 1. Is always 1. So any digit has got the power 0, that value is 1. Any digit, any alphabet, anything, that standard rule says a to the power 0 equal to 1. That you can remember this. In place of a, there may be anything, that is a B, C, D, E, F, G, H, I, J, K, L, M, N, O, anything, all alphabetical letters, that power is, if power is 0, result is 1. Result is 1. So a to the power 0 equal to 1. Right? You can note it down. This will be your fourth law of integral exponents. Suppose sometimes you get 2 to the power 0 plus 3 to the power 0 plus 4 to the power 0. What is the result? So what will you say? What is the value of this? What is the value of this, gentlemen? What is the value? So certainly you will say, sir, its power is 1, its power is 1, its power is 1. So result is 3 is the right answer. Result is 3 is the right answer. So gentlemen, we must remember this, and with this I have cleared your four law of integral exponents. And next day we'll discuss in detail. If you want the notification in advance for the same, that you can subscribe, or if you like it. If you like to share it, and please subscribe it. Right? This will work as a motivation for me, and you must visit my channel, that is a Gupta Sir Math Hub YouTube channel. You must visit. Right? Just see there what are the contents are there. Right? Whether it is useful for you, you must stay there. Right? Okay. So with this, I have cleared four law of integral exponents. Next class we'll discuss more. Right? Thank you. Thank you. Thank you very much. We are meeting soon. Right? Thank you. You can note it down.